Welcome back to 5-Minute Chemistry. Today we are going to be talk about the structure of the atom in more detail. So in our previous session we talked about how after discovering that negatively charged particles can be removed from the atom, they made this plum pudding model of the atom which has the electrons as these negatively charged particles that concentrate the negative charge inside the atom, and all the other parts of the atom are slightly positively charged, so all the positive charge is kind of spread out evenly with a much lower charge density, but in the end, of course, the positive and the negative charges have to balance each other out to get neutral atoms. So they wanted to prove this model by using the newly discovered alpha particles. So alpha particles are positively charged particles, very small, with very large positive charge density, and you can get them flying from an alpha source. So radioactivity was discovered during these times, and what they were expecting is that these positively charged alpha particles would mostly just pass through the atoms because the positive charge of the atom is very thinly spread out, so this very small alpha particle would be able to just pass through the positive parts, and if the particle flies quite close to an electron, due to the attractive force between the electron and the alpha particle, the trajectory will be deflected by a little. So they set up this experiment in which they used a very thin gold foil. So they used the foil because in the foil it's very thin, so there are not that many atoms next to each other, so the alpha particles can pass through this film more easily. And they put the alpha source on one side and some kind of a sensitive film on the other side, like a sensitive screen. It was kind of like a photo screen, like if you've seen old X-ray images, so that kind of screen was used here. So if the alpha particle impacts this screen, the black color will turn to white. And what they were expecting from this experiment is that most of the alpha particles will just pass through straight, so they will see a big white dot straight on the other side from the alpha source of the film, and then some of these alpha particles would be deflected somewhat, so you would see a few of these white dots on the sides also. But in reality what they see is they had a little more of these dots on the sides than they were expecting, so most of the alpha particles actually passed through straight, so the big dot was in the middle, but they've seen a little more small dots than they were expecting. This anomaly was not big enough to disprove the model, but they got suspicious, so they did an extended experiment. Because if you are doing science, what you want to do is you don't just want to check whether the positive predictions come true. So if you are expecting signals somewhere, you look there and you see the signal. You also should check where your model predicts that there would be no signal. Is it really true that there is no signal there? So they extended this experiment by having the screen extended even behind this gold film. So the plum pudding model did not predict any reflection of the alpha particles. So the alpha particles should not cause any coloration on the screen in the backside here. But what they've seen is that once they put in the alpha source, there are a few dots that show up in the back. From the plum pudding model, they were not expecting any reflection because the positively charged part of the atom was supposed to be spread out and very low charge density, so there would be no reflection. But there was deflection, so they had to make a new model for the atoms, which could explain that not just most of the alpha particles pass through, some of them get a little deflected, but also explains that some of the alpha particles actually get reflected backwards. So, to get this reflection, they had to introduce a very small and high charge density positive part into the atom, which they called the nucleus. So the atom actually has the nucleus, which concentrates the positive charge, and then has the electrons, which are the negatively charged particles in the atom. So this was the new model that they made up. And so now it was proven that the part of the atomic theory of Dalton that atoms are indivisible is not true, because we have the electrons, which are small mass negatively charged, can be easily or relatively easily removed from the atom, and we have the nucleus, which contains all the positive charge and most of the mass of the atom. So later, it was figured out that the nucleus is actually also made up of its own particles. So in total, we have 3 subatomic particles that make up the atom. So electron, which has a symbol of E-, and its charge is just defined to be -1 because we don't want to use the SI units. The electron is very small, so expressed in an SI unit, the charge would be very small. So we just use this scale defined based on the electron charge. So its charge will be -1. The electron's mass, it's also not in SI units. We will talk about these mass units later. 5.5 times 10 to the -4 is the electron's mass, while proton, which is symbolized with P+, has the +1 charge, so its charge is the same, but with opposite sign as the electron, and its mass is around 1.0073, so it's about 1,800 times heavier than the electron. The last particle that was discovered is the neutron, which is called neutron because it's neutral, it doesn't have a charge, its symbol is an N. Its mass is almost the same as the proton. So the atom has to have the same number of electrons and protons to be neutral, and most of the mass in the atom is actually carried by the nucleus, and now we can see how this mass is shared by protons and neutrons. Okay, so this is it for today, and I will see you tomorrow.